Stellenbosch University says it's pioneering research that could help identify the victims in cold cases. Researchers are using digital facial depictions of 5 people who've been unidentified for a long time. Their remains were found between 2020 and 2022 in Philippi East, Mitchell's Plain, Mowbray and Lintegere. The realistic images, which we will show, may bring closure for families who've been desperately searching for their loved ones. Dr. Kathryn Smith is a senior lecturer in the Department of Visual Arts at the University of Stellenbosch. Dr. Smith, good afternoon to you. So we can all understand this problem where people know that there's a body, it's been decomposing for some time, it's difficult to identify. How does your technology work?
Well, we provide an entirely digital workflow, so we don't have to handle the remains ourselves. In VizLab, we either acquire a direct replica of the skull via CT medical imaging, usually CT scanning or 3D surface scanning. And then we have a system called Geomagic Freeform, which enables us to sculpt as one would manually, but we're working with virtual clay and a haptic arm, so it provides touch feedback for while we're working. And we essentially can create a face model, recreate face shape by following anatomical patterning, and then textures, what we refer to as textures, but what are understood as surface detail, is then applied to that face model to create the plausible, realistic faces that you see.
I mean, it's a little gruesome, but how much material do you actually have to work with? I mean, is it literally just a skull?
Yeah, so the skull is one part. Contextual information is really important as well. So within this particular project, this was a very collaborative effort as part of a research consortium involving researchers from UCT and myself at Stellenbosch. And I end up with all of their really amazing data, and I have to turn that into a piece of visual communication that the public can relate to. And that's a really important piece of this puzzle, because when you have what we refer to as complex cases like these, found skeletonized, heavily decomposed, they're beyond the point of visual recognition, and they can't be fingerprinted. If the primary methods of identification are no longer available, then a facial depiction is really the last chance that we have to try and prompt recognition by someone who is familiar with this person in life, and then it's a way to produce investigative intelligence, investigative leads. So this face needs to do a lot of work in terms of communicating aspects of this person's story. And in our work, we're really taking a humanitarian approach here, and trying to move from the skull, which is quite easy to abstract, to a sense of these individuals as people.
So you don't need a lot of material. I mean, you wouldn't be able to tell from a skull, obviously, much about the texture or the color of the skin, the complexion of the skin. You wouldn't be able to tell much about the hair. You wouldn't be able to tell if a man wore a beard or not, for example. You do need some other information to go along with the skull.
Yes. So we can tell quite a lot about individual facial features. And this is where the contextual information that I mentioned and this collaborative process that we've been part of. So I work with a team of forensic anthropologists, forensic genetics. So facial phenotyping can tell us a little bit more about facial appearance than we used to know. Stable isotopes can tell us something about an individual's diet over time. Forensic pathology, obviously we're working at the instruction of the forensic pathologist, always refers cases to further expert analysis. That's in terms of our law in this country. And ultimately we wanted to work on these as a way of assisting with cold cases because it's such a huge problem. But yes, I do need additional information. There's a lot that one can tell from, or one can infer by contextual information, but sometimes all you get is a dry skull, and it's true then that a lot of the superficial details would then need to be inferred, but there is an enormous amount that we know about face shape, and following certain methods and procedures, we know that we can produce an accurate face shape for about 70% of the facial surface with only 2 millimeters of error. And that's been validated through different studies over time.
Sure. There's something almost unique around human faces. I read once someone described it, a face-to-face conversation is just the most amount of communication bandwidth that there can be. When we talk to you now on television, it's your face that we want to see, not the back of your head or your feet, you know.
Absolutely. Yes.
So there's something about faces and communication. When you create these faces, they must be more complex than almost anything else. They move in certain ways. They're a combination of textures and colors and different features.
It's true. And a lot of the work that we do, we are highly aware of the limits of what we're able to do as well. So these depictions are frontal, you know, and that's because our passport and identification photographs, the bureaucratic standard for facial identification, is a frontal-facing image and a lateral-facing image. Meanwhile, we know that the most facial information we get is if the face is at a three-quarter angle, because faces are three-dimensional. You know, they're not flat surfaces. Everything that you say is absolutely true. So it's also really important when we're coming to make decisions about what we refer to the facial reconstruction process as the anatomical reconstruction. The depiction process is when we're making those faces look plausible, look realistic. We have to be very careful as forensic artists not to add information that we can't scientifically justify. So questions around, you know, implying emotion, implying personality, that gets into a very gray area that also is an ethical consideration because we didn't know these people in life and we don't want to impose character on them that we can't possibly know about or justify. That doesn't stop members of the public, however, projecting onto these images, and that's a whole other conversation.
Indeed. This technology that you're using, I mean, obviously it's quite difficult for each and every case at the moment. But do you expect it to become more widespread? Everybody that's found in this position, you'll probably be able to do this for one day?
Well, that is something which is a dream of mine. I mean, whether or not that's physically possible is a question. What I'm hoping to see in the field, and I know colleagues in the field are working on this, is the extent to which AI might be able to help not necessarily automate, but understand a little bit better, not only how to do these quicker, because right now it's similar to a manual sculpting process. It's just happening within a computer, and there's benefits to that because we can make layers transparent and continually validate and check our own work as we go. Whereas if you're modeling on a replica of a skull with modeling clay, traditional modeling clay, the minute you cover up, you know, the surface of the bone, you can't you've got to peel it off to check what's underneath again. The digital space really offers an enormous amount of flexibility to change, you know, the body mass. You know, is someone underweight, overweight, etc. We can update reconstructions when more scientific information comes in, should we need to. So I think there's huge potential with AI going forward. Attempts to automate these things has proven to be not as successful because we end up with so-called types of faces rather than individual faces. And in forensic cases, we are absolutely trying to generate leads around individual identification.
Dr. Smith, it's the magic of the undo button, isn't it? Thank you very much indeed.
Exactly.
Dr. Kathryn Smith is a senior lecturer in the Department of Visual Arts at the University of Stellenbosch.